Well, hi everyone. Time for another Teton Pass update. The last video I did was July 1st, 2024, just a few days after WYDOT reopened the bypass after a flurry of activity over about a 3-week period. According to them, they designed and constructed this bypass on a steeper, tighter curve, and there's been not a lot in the news, unlike when this bypass was going in. WYDOT had constant updates. When I say constant, I mean virtually every day they had new updates. They had photos, they had narratives. Now it's extremely quiet now that they're going into the rebuild phase to restore the original embankment that failed. Now the basis for this video, there's been some local news reports. I also have a couple of anonymous sources who's provided some information to me, and it's quite interesting. I'll go over that. I'll give you an overview of what's planned to complete this rebuild. They're hoping to do it by the end of the year, but that's looking to be increasingly unlikely, as I'll provide the details about. Another source of information comes from Geologists of Jackson Hole YouTube site. Apparently WYDOT gave a presentation towards the end of July 2024 giving an update as to how the original large slide occurred, what they did to construct the temporary bypass, and what they're going to do to completely rebuild this embankment and restore it to better than original condition, that is prior to the failure. Also at the beginning of the video, there's this very good overview of the geology of the area. So that part's worth checking out. The rest of the video was plagued with audio-visual issues during their Zoom call, so it was difficult to hear in certain spots, and there was a lot of dead space while they were trying to work out their technical issues, but I've got it summarized for you so you don't have to get too deep into that video unless you really want to. So for this presentation at the Jackson Library, key players for WYDOT is resident engineer Bob Hammond, district engineer John Edens, and WYDOT geologist James Dahill. So before I get into all the details of what's going on, let's cover briefly an overview of what's happened to date. So as I mentioned, sometime the evening of, I say evening, the night of June 7th or the early morning of June 8th, this entire 70-foot plus roadways embankment failed catastrophically. There were plenty of warning signs though, and this is one of the things that alerted to me this whole story. I've done multiple videos about this slide and subsequent efforts to restore it on a temporary basis. I've been very skeptical about the pace, the rapid pace for the rebuild, trying to get traffic back on this road. I know that's somewhat controversial. I think there's a vocal minority that just says, you know, we don't know, we don't care, just get the road open, we got to go to and from work. And I can understand that sentiment, but there are bigger issues involved. As I said, I was skeptical whether they had enough time to perform a geotechnical investigation consisting of boring, soil sampling, laboratory testing, evaluation, and analysis. That process for an area the size of this slide would be typically expected to take 6 to 8 weeks. And yet, WYDOT Bob Hammond said that they did the design of this bypass that involved 30,000 cubic yards of compacted fill over a period of 1 or 2 days. And then inside of 3 weeks, they had it built. But the other thing I was very critical of at the beginning is how could they not know that this roadway was about to fail catastrophically? Well, the short answer is movement has been going on in that area for, according to WYDOT officials, decades. In fact, they put an inclinometer in there last October of 2023. But when I first saw these photos of the cracked roadway right before the catastrophic failure occurred, to me it looked like, hey, this whole thing's going to cut loose. Get everybody out of here. That's not what they did. The circular pattern of cracking indicates a large mass of material that's moving downslope. The cracks got wider and there was some downhill offset in the vertical plane by Friday afternoon. So then WYDOT scrambles to get a contractor up there. And I've mentioned this in a previous video, but I didn't understand the source of this because there was a press release from Wyoming DOT saying they were stripping the asphalt pavement to reduce the driving forces in hopes of stabilizing this slide. That's sort of like asking an elephant to go on a diet by shooing the mosquito that's on its back. I mean, the amount of the difference that removing a few inches of asphalt would make is trivial. And not only that, it put workers at grave risk. So according to Bob Hammond, they had the contractor up there from 6 p.m. to 10 p.m. on Friday, June 7th, and they knocked off for the night on June 7th, that Friday evening. And mere hours after that, this whole thing cut loose. And in fact, I don't quite understand taking a nominal amount of asphalt off the roadway when the actual equipment used to do it provides far more additional loading than what would be removed in a given area for the paving. When I first covered this, I thought it might have been some miscommunication from their media folks, that surely a technical person wasn't involved with that statement, but it came from Bob Hammond. You could see it for yourself in that library presentation. So this goes over the timeline that I've talked about. They apparently took a reading of this inclinometer that was put in last year on May 15th. The thing that was never mentioned that I could find is why didn't they take a reading of this inclinometer on June 6th? There was enough cracking to cause a motorcyclist to crash and become injured, and it totaled out his Honda Goldwing when he hit that offset crack in the pavement. That would have been a good time either on Thursday the 6th or Friday the 7th to get out there and take an inclinometer reading, but they didn't do it apparently. And the other thing I mentioned is it was really good luck that this roadway was closed. There was a mudslide that covered the road a few miles away from this area of milepost 12 where the overall failure occurred, and this mud flow kept traffic off the roadway in the hours leading up to the failure that occurred at night. So this is their response. As I mentioned, they did the temporary detour design in the field in 1 or 2 days. In fact, Bob Hammond said he did it on that Sunday, June 9th, and I think he said there was a little follow-up the next day on Monday. But, you know, how could you possibly have enough information at hand to do that? And I'll come to that here in a second. So they did some surveying, aerial photography, and then they got started right away with consulting with their geologists on staff. So the bypass they constructed is about 600 feet long with a grade of 11.2%, and it's a sharper curve. Federal Highways wants a limit of 10% on the grade, so they're beyond that. And then they said the geotechnical analysis completed meets minimum requirements as outlined in the guidance from FHWA. Calculated factor safety for stability of the detour exceeds 1.2. Well, maybe or maybe not, as I'm going to cover here shortly. Just a few more photos of them getting ready to open up this bypass section in late June. Apparently there's already been some crashes into the concrete barriers that they've installed on the outside of this curve. So Bob Hammond mentioned that there's a drainage way, natural drainage way, that became apparent upon further studying of the contours of this location. And in fact, John Eddins in this presentation mentioned that there were observations of water gushing out of the slope. So after the failure, WYDOT scrambled and got a drill rig there to start taking geotechnical soil samples, presumably to send to the laboratory to run strength and index tests to feed that information into a slope stability analysis to make sure that their geometry and what they were planning to do and the distance from the failed section of the embankment would all be adequate. So going back to the question, did they have enough time to collect the data? Thanks to this anonymous source, I have this memo from RJ Engineering and Consulting Incorporated. They're located in Colorado, from what I understand. And this letter is dated June 28th, the day they opened up the bypass to traffic. The purpose of this memo was to provide the results of the global stability evaluation, slope stability analysis. So it says, site assumptions. Due to the emergency nature of the work, RJ is working with WYDOT in a team fashion and has developed and reviewed various cross-sections and subsurface conditions throughout the detour construction process. RJ has made the following general assumptions regarding the site and stability analysis. The first bullet point here, soil parameters were mutually agreed upon with the design team for the stability analysis. Okay, that's the only place they talk about the shear strength parameters. And let me emphasize why this is important. So you can perform an analysis of a configuration for a slope and determine the critical shear surfaces for the minimum factors of safety and compare it to your design requirements to see if you have an adequate slope that's going to remain stable. that analysis means nothing unless you've selected appropriate soil strength parameters. In fact, I've done many slope stability analysis for dams, levees, highway embankments, and I've been a senior geotechnical engineer for many years now, and in prior positions I would interview mid to senior level geotechnical engineers to come into my department or company, and one of the things I would ask them is, what's the trickiest part about doing a slope stability analysis? Well, the clear answer is coming up with appropriate soil strength and index properties. That's the hardest thing. And the mechanics of the program is a secondary thing. So it's really important. In fact, about the hardest I chewed on a senior engineer one time was I had tasked him with compiling soil parameters, soil strength values for an embankment that was going to be excavated in an existing dam. And this was a Corps of Engineers project, and there was literally volumes and volumes of laboratory test data. And then this engineer gave me a summary of his results, and I said, well, you didn't cite your reference for this information. Oh, I just assumed some reasonable values. I'm like, why would you assume anything? There's lots and lots of data. So it can be appropriate to make assumptions if you don't have the information, to run preliminary calculations. But the central question, or one of the central questions at the time when this bypass was being built, is do they have the information that they need? And when you present the results of a slope stability analysis, at least the ones I've done, I devote a lot of time and detail to the soil strength and other properties, the density and so on. Because without that information, you can't really put the results of the stability analysis into context. So that's rather curious that they just agreed that, hey, we'll use these values. Maybe those values were based on laboratory test results, but if that was the case, why wouldn't you say that? Why wouldn't you say, we performed 5 consolidated undrained triaxial shear tests, and this is the average fee angle or the minimum fee angle, or this is the cohesion value, and we selected lower bound values to be conservative. I mean, this is the kind of discussion you have when you present results like this, at least in my experience. Let's look at some of their other assumptions. Elevated surface and groundwater was a significant contributor to the failure of the embankment. The embankment was likely nearly saturated in the lower half just prior to failure. The embankment materials exposed consist of blocks, cobble and boulder-sized material in a fine-grained matrix. The embankment soils have significant cohesion. The current headscarp slope faces are standing at 60 degrees or steeper in places. Well, you certainly wouldn't want to count on that for very long. Groundwater levels within the current embankment have dropped but are still present. Okay, so that's the overview. Let's look at a few other key excerpts from this letter report. So they selected a couple of lines to run their cross sections for slope stability analysis. And as you would expect, they had a factor of safety below 1 for their pre-failure analysis. And you can see these red lines, that models the surcharge loading from traffic and construction equipment. And you can see overall for this slope, it's the northeast cross section, factor of safety of 1.34, although there are other shear surfaces that have a much lower factor of safety. Here's one of 1.19. That failure surface would take out the facing material pretty well into the slope, and somebody would say, well, yeah, but that didn't affect the roadway. Yeah, but when that happens, these failures can be progressive. So you get one area slides off, and in short order, potentially another slice moves downslope. So that's a bit of a worrisome factor of safety, in my opinion. And in this other section, they have overall factor of safety of 1.21. So let's look at their summary. They basically say that the detour has a factor of safety of a 1.2 for the current slope and water conditions. 1.2 is too low, in my opinion, to begin with, and I'll go over that here shortly. It said headscarp slopes faces may be at a factor of safety of less than 1.2, but the factor of safety between the slope and face and the current detour roadway is greater than 1.2. That doesn't really address the potential for progressive failure. So for the $64,000 question, did they have the information at hand in order to perform this design and construction of what was called at the time a temporary bypass? And it's not clear to me. I mean, the reference to mutually agreed upon soil parameters, to me, that's not exactly transparent. And I'm not saying I understand the motivation for that. I'm just saying that's the result. If someone had included information about the shear strength properties, the conditions for those strength properties, other index properties, anybody who's familiar with this type of analysis could input their own model and calculate the overall factor of safety for various sections, as well as the critical shear surfaces. And you just can't do that when somebody just essentially gives you the bottom line result. It's sort of like going up to somebody and saying, the answer is 14. Okay, great, but what was the question? So I don't understand why they didn't include an appendix of the soil information that they use for this analysis in terms of boring data, laboratory test results, why that information wasn't summarized in the memo in terms of what they use for their analysis. It's a puzzler to me. And we talk about federal highways, and at the presentation also, WYDOT mentioned AASHTO. So let's look at both federal highways and AASHTO guidelines for embankment slopes. For slope stability analysis of significant fill slopes, the desired minimum factor of safety is typically in the order of 1.3 to 1.5, depending on the levels of importance and risk and the uncertainty of the slope analysis input parameters. So in other words, the less certain you are about the soil values that you're using, the higher factor of safety, or the higher end of the range, is where you should be. Now, this is a summary of AASHTO. It's hard to get your hands on AASHTO documents, and they're super expensive. So Washington DOT summarized current AASHTO requirements for highway embankments. All bridge approach embankments and embankments supporting critical structures shall have a resistance factor of 0.65. That is a safety factor of 1.5. Critical structures are those for which failure would result in a life-threatening safety hazard for the public, or for which failure and subsequent replacement or repair would be an intolerable financial burden to the citizens of, in this case, Washington State. So, you've got people on this road. So it's not temporary. It's not non-critical, in my opinion. So I don't understand how anyone could really support such a computed low factor of safety of 1.2 under these circumstances. And I've mentioned this in previous videos. WYDOT, you've been issuing updates, or you had been, when the bypass was going in. How about some updates showing your work? I mean, I'm not the only one raising these questions. It's been a hot topic with a number of people that, on one hand, they're applauding WYDOT for their quick response, and at the same time, there was a lot of skepticism about how much risk-taking was occurring. So as I mentioned in a previous video, Wyoming DOT sent out a request for qualifications to select a design-build team to rebuild the main section of the highway embankment. And part of this is that they wanted to be done by mid-November with all the design and construction work. Another requirement was not to close the temporary bypass while they were working on rebuilding the main embankment. All right, so let's look at a couple of headlines. This is mid-July, Cowboy State Daily, and again, there's links for these news articles. Permanent fix for Teton Pass, rebuild the mountain, could be done by November. And it talks about their quality-based selection as opposed to cost-based selection. And I understand the Highway Commission approved a $12 million contract to start this work. There's going to be two contracts. This was the initial contract for the design and construction of the rebuild for the embankment. So that's nearly 2 months after this initial failure occurred. Now here's another headline. Now we've gone from mid-July to mid-August. This is from Jackson Hole News and Guide. The headline is, Teton Pass rebuild begins, though drivers may have to use bypass all winter. Well, wouldn't that be lovely? Read a couple of quotes from that article. Temporary Teton Pass bypass may be temporary for a little longer than expected. As the Wyoming DOT begins the first phase of rebuilding portion of Teton Pass that collapsed in a landslide, officials say the work may take longer than they originally projected. In late June, after building the bypass in 3 weeks, a pace that was both praised and scrutinized, resident engineer Bob Hammond said engineers plan to have the permanent fix done by mid-November. And that's usually when it starts snowing. And you're not in a position to place and compact fill once it gets cold enough for the ground to freeze. Bob Hammond continues, it could snow at any time up there, and we have contingencies going into place, so we have everything we need and then some in case we do have to use the detour over the winter, he said. It's very possible. And continuing on, if it's not completed by mid-November, they've got a backup plan, which includes installing chip seal, which I'm recording this video on Wednesday, August 21st, and I've heard from a source that they closed the bypass today to do this chip sealing. Apparently also they're planning to remove these concrete barriers and install guardrail on the outside of the curve. And again, that's another measure that would indicate that they're planning on having to use this so-called temporary bypass throughout the winter, because the blades on these snowplows tend to catch on these concrete blocks versus a guardrail. Here's a slide showing the groundwater level inside that big fill slope. And as you would expect, it's highest in the spring and decreases throughout the year. But another problem could be if they end up using this bypass, this temporary bypass as they call it, through to the spring, depending on how wet the spring is, they could be right back where they started in terms of having stability problems. Again, that depends on how much of this new construction they can complete by then. So this is what the rebuilt embankment is going to look like. You see this gray area. So according to some of those folks that attended that WYDOT presentation at Jackson Library at the end of July, they're planning on using low density fill materials, probably styrofoam. They're going to pin the base of the fill slope into the underlying foundation soils with 9-inch diameter micropiles. They're going to install a lot of drainage, particularly at the base of the new fill slope. And they're going to have to bench and install soil anchors to stabilize that very steep slope. As that memo referenced, some of those faces are greater than a 60-degree angle. So as I mentioned, Ames Construction was awarded the prime contract, this $12 million to get things going. Some of the news articles I read suggested that Ames would be installing the soil nails and doing these terraces. In my experience, that's typically the purview of a specialty geo constructor like Keller. Keller's apparently part of this team. Certainly Keller would be installing the micropile, I would expect. But Keller, I understand as of today anyway, at least I haven't heard whether their contract's been secured. At that presentation at the Jackson Library, Bob Hammond said that they were having to do cost reviews independently to make sure they were in good shape to award this second phase of the contract. So let's just look at what soil nailing entails. You have to cut a bench, and this work's done in a top-down fashion. So you start at the top of the slope typically, you excavate a bench, and you install these soil anchors at an angle, and there's a facing plate that's locked off to stabilize the slope. Here's some video showing that. They've installed the anchors, they've got a wire mesh, and then they're installing shotcrete to protect the slope face. Keeps the water away. And it just shows you the micropile installation here. Usually you're drilling a cased hole, you're inserting a high-strength reinforcing bar, and then you grout the space between the bar and the casing. And then when that's set up, you install a facing plate and a locking nut, and you torque it down so you can put a pre-stress on those anchor rods. Here's the styrofoam I was talking about, low density fill. It seems amazing that you could use something like styrofoam in a highway embankment, but it's becoming increasingly common to limit settlement, to reduce the potential for a slope failure, and so on. This Jackson Library presentation, they also mentioned several other areas that have had either ongoing or previous slope stability problems. In fact, this press release came out August 8th. Emergency slide repair work to be completed on Interstate 90 east of the state line. There's a photo of this embankment cutting loose. So to summarize, I'm still concerned or curious as to where they got their soil strength parameters to use in the stability analysis. I would encourage WYDOT to make that information available, post it on your website. It looks like they're taking precautions, which is prudent, I suppose, but it indicates more likely than not that this rebuild won't be done by the winter, which is, I think, pretty hairy for those drivers. And, you know, doing the hard thing is hard. The hard thing would have been keeping that bypass closed and just simply designing and building the permanent fix and not mess with this temporary bypass. Now that's for everybody there to decide. I'm saying from a safety and project management standpoint, I think I would have thought that would have been the way to go. Especially in the early going, WYDOT wasn't making any commitments as to when the road was going to be reopened. So there was a window of opportunity to manage expectations and saying, you know, as bad as it is, this road's going to have to be closed for a while, and we're just going to do it once and we're going to do it right. But instead they went with this so-called temporary route that may not be quite so temporary, and they've, I think, made it much more difficult to implement the construction of the permanent rebuild. So one thing I'll mention too, I appreciate those of you who have provided tips, and I respect your desire to remain anonymous. If any of you others out there have some information that you could pass along, my email is info@ftnc.com. I want to send a shout out to the channel members. I really appreciate your ongoing support. I also want to send a shout out to those of you who have provided super thanks. That's another great way to support the channel. Check out the links in the description. I have some free digital downloads on some pretty interesting things. The biggest civil engineering disasters of the past 100 years. And then an overview of NASA's Artemis program to return humans to the surface of the moon. So thanks very much, everyone.